All right, if we're given percent masses or percent composition of the elements, we're going to follow all the steps of the empirical formula, and then we're going to follow all the steps of the molecular formula. Okay? So let's look at an example here. Let's do empirical formula from experimental data. And then, so the first step is to write down all the masses that I have for everything, okay? Now, this says that I've got a 3.24 gram sample of titanium, okay? So I've got of Ti. I know it's Ti because if you don't know it's titanium, titanium is on the periodic table. You can go and look at the periodic table. Ti is number 22. Titanium is number 22, so it has it is Ti. Okay, so I'm going to write down my mass for that. Now, we say that it reacts with oxygen, so it's reacting with oxygen, and it's forming 5.40 grams of the metal oxide. Now, this is the compound, right? And it's asking me for the empirical formula. So I need to find out my mass of oxygen because I want my mass of my elements that are in the compound. So the thing that I use here is the law of conservation of mass. So law of conservation of mass states that mass cannot be created or destroyed. So this is my product, right? And then titanium is a reactant and oxygen is a reactant. And that's the only thing that I have reacting with one another. So if I have the mass of the product, so if I have this mass, the mass of the product, then I can find my mass of oxygen by taking and subtracting from the titanium. So I have to take 5.40 grams of oxide subtracted from 3.24 grams of Ti. And that's going to give me my mass of oxygen in the compound. Okay, so I can calculate this out. So I've got 5.40 minus 3.24, and that gives me 2.16 grams of oxygen. So I can write that down. My second step is to convert my mass to moles. So then I'm going to take my grams of titanium and I'm going to go from mass to moles. So I'm going to have my grams on the bottom, grams of titanium on the bottom. Now, again, this is going to come from my periodic table, right? So titanium's mass is 47.90. That's over 1 mole, so underneath 1 mole of titanium. And same thing here. I'm going to go through my mass of oxygen. So I've got mass of oxygen, 1 mole of oxygen on the top. And then I can go to my periodic table. And I have the oxygen's mass is 16 grams. So then I calculate my moles. And for titanium, I'm going to look here for my sig figs. I've got 3 sig figs. So I'm going to put this into scientific notation just so I don't have some crazy numbers. So I'm going to put 6.76 times 10 to the minus 2 Ti. And then I need to go back and calculate for oxygen, right? So oxygen, I have 2.16 divided by 16, and that gives me 0.135 times 10 to the minus 1 moles of oxygen. So now I get to write my pseudo formula. So I know that titanium has to come first because titanium is a metal. So I'm going to put 6.76 times 10 to the minus 2 subscript here. And then I'm going to put oxygen. And I'm going to put 1.35 times 10 to the minus 1. Okay, so those are my subscripts. The next step that I have is I just have to divide by my smallest subscript. So my smallest subscript here is 6.76 times 10 to the minus 2. So now this guy goes to 1. Okay. And then I can calculate the 1.35 So I've got 1.35 times 10 to the minus 1 divided by 6.76 times 10 to the minus 2. And that gives me 1.997. So I can go ahead and round this to 2. So this would be TiO2. So then my formula here, and I didn't have any weird fractions or anything like that, so I've got TiO2 is my empirical formula for this guy. Okay, so I skipped 5 altogether because I got a whole number. So now, I've been given the molecular formula and I've been given percent composition. So I'm looking for the molecular formula and I've been given percent composition. So my first step here is to take all of these percentages and turn them into grams. So they're grams. Okay. So all I'm doing is I'm just changing my percentages to grams. So these all go to grams. Okay. And then, so again, write down my masses, right? So I've got 2.2 grams of hydrogen. I have 26.7 grams of carbon, and I have 71.1 grams oxygen. Second step, right? I'm going to convert from grams to moles, right? So I've got 1 mole on the top for all of these. So I've got 1 mole of H, and then I'm going to have my mass of H. Okay, same thing for carbon. I'm going to have my grams of carbon and my 1 mole of carbon on the top. And then the same thing for oxygen. I'm going to have grams of oxygen, 1 mole of oxygen. Okay, so I need to go to my periodic table and I need to look up my molar masses for these guys. So hydrogen has 1.01, carbon has 12.01, oxygen is 16. So again, I go back over here, okay, and then I just start calculating, right? So I'll calculate my moles out. So this gives me 2.178 for hydrogen. So I'm just going to round it to 2 places behind the decimal. So I've got 2.18 moles of hydrogen. And then I can go to my calculator and calculate out for carbon. So 26.7 divided by 12.01. So 26.7 divided by 12.01. That gives me 2.22. 2.22. So I've got 2.22 moles of carbon. And then oxygen, I have 7. And that gives me 4.44. So 4.44 grams of oxygen. So then I write my pseudo formula, okay, using my number of moles that I got from my step 2. So I would write, if it were me, I would write C first, okay, and I got 2.22. And then I would write my hydrogen, which is 2.18. And then I would write my oxygen, which is 4.44. Okay. And then the next step, I would divide these guys by 2.18. Okay. This guy definitely goes to 1. This guy most likely goes to 1. So if I take 2.22 divided by 2.18, that's pretty close to 1. And that gives me 1. So 1.0, which is close enough. And then 4.44 divided by 2.18, and that gives me 2.03, which would be 2. So this guy goes to 2. So then my empirical formula for this guy is CHO2. Okay. Now I was given in here my molar mass. So I was given 90.04 grams per mole. That is my molar mass for the compound. Okay. So this is my molar mass of the molecular compound. Okay, so molecular compound has a molar mass of 90.04. So my next step here to get my molecular compound, because I'm wanting my molecular compound. So this is just my empirical, right? So this guy, is my empirical formula, okay? So to get my molecular formula, I need to calculate my molar mass of this guy, of my empirical formula. So if I've got my empirical formula, so I've got C, which I know is 12.01, and I've got one of those. I've got hydrogen, which is 1.01, and then I've got oxygen, which is 2 times 16. So that equals to 32, 1.01, and 12.01. So I have 45.02. So that was my first step there. Now I'm going to take my molecular formula mass, so my molecular mass that I highlighted up here. So I got 90.04. And I'm going to divide it by the molar mass that I calculated over here. So I've got 90.04. So this is my molecular. And then I'm going to divide that by my empirical, which is equal to 45.02. And that should give me a number. So 90.04 divided by 45.02. And that gives me exactly 2, which is good because I want a whole number out of that. Okay, this is equal to 2. So I'm going to take my empirical formula and then I'm going to multiply all my subscripts by 2. So I'm multiplying all of these by 2. So it's 2 times that, 2 times this, and 2 times that. So that gives me, for my empirical formula, is C2H2O4. And that is how we get our empirical. So that was the last learning objective for Unit 3, which is learning objective 18, determine the empirical and molecular formula of a compound.